Bismillahirrahmanirrahim. Assalamualaikum. My name is Ahya-Elhafiz bin Ahya-Elmuddin. So today I'm going to present about my final year project thesis. The topic of the thesis is analysis of solar dryer exhaust air recirculation effect on regenerative desiccant. And as an introduction, we use mixed mode type of solar dryer, and a mixed mode solar dryer is a combination of solar radiation and preheated air in solar collector. So and also in this project we use desiccant to enhance the performance of solar dryer. Okay, then the most common use desiccant is silica. So we use a custom-made desiccant to ensure that the desiccant can absorb most of the exhaust air humidity to ensure the dryness of the air and the dryness of the product. In this, other than that, in this project, we observe the time taken, temperature, and humidity of air at the inlet and outlet of the solar dryer using sensor. Okay, the problem statement is that the previous mixed mode type of solar dryer released the exhaust air to atmosphere. So the waste exhaust air is high in humidity. So to overcome this problem, we use desiccant to absorb moisture from the high humidity of exhaust air. And then the research objective is to determine the suitable range of air recirculation needed for the system and to calculate the rate of absorption of exhaust air by the desiccant bed. So the desiccant is used to absorb the moisture in exhaust air. Then we have to calculate the rate of absorption of the moisture in exhaust air. Okay, now we I'm going to share about the scope research. So the type of the scope is we only use mixed mode solar dryer type. We use desiccant in this project. We use solid stationary desiccant. Then the rate of absorption is analyzed from the data collected, and the data collected is from a sensor. And the overall dimension of solid desiccant bed is 800 mm in length, 252 mm in width, and 254 mm in height. Then the overall dimension of solar dryer is 2254 mm, 0.5 mm, 1656.25 mm in width, and 3239.11 mm in height. So the exhaust air that will be recirculated back inside the system is about 12 to 15% only. Then this is the process flowchart for this project or research. So first of all, we start with research finding, and then we specify parameter. What parameter do we want to use, and then calculate the desiccant absorption and flow rate research and the flow rate. Then after we get the data, we collect the data, then we analyze the data. If the hypothesis is accepted, then we continue to report writing. If not, then we have to specify the parameter to ensure the effectiveness of the project. And then this is the research design. It all starts from up here, where air will be sucked in through a pump and a double pass through the solar collector to accelerate the heating process of air. And then the air will travel down and straight into the drying chamber, which we dry the product. And the two reflector here is used to increase the temperature inside the drying chamber. So and then a portion of 12 to 15% of exhaust air is recirculated back and recirculated back to the system. The high humidity exhaust air is then being sucked the moisture by the desiccant at the desiccant bed. The other is released to the atmosphere. So this is the solar dryer. The overall dimension has been stated at previous slide. So the desiccant solar air dryer consists of multiple components, which is solar collector, desiccant bed, uh, exhaust air, drying chamber, also absorber tower, and all the filter and piston and valve is used in the solar. And then only a portion of 12% to 15% of exhaust air will be recirculated back in. And then this is the overall view of solid desiccant. So the overall dimension have been stated also in previous slide. The ambient air will travel through the inlet here, then pass through the outlet, to pass through the dry desiccant inside the desiccant bed and out from the outlet. The desiccant bed will absorb moisture, so the air that pass through here is only the exhaust air. Okay, so this is the regenerative process. Okay, and then the parameter is known as limitation or variable. And in this project, the capacity of product that wanna be that been dry is 10 kg. The initial moisture content is 87%, and the final moisture content is 7%. Means the moisture has been removed 80%. Then the solar radiation is supply the energy from sun. Then the ambient temperature is 30 degrees Celsius. The average ambient temperature is 30 degrees Celsius, but the drying temperature inside the drying chamber is about 70 degrees Celsius. And the relative humidity is 15%, and the drying time is 4 hours. So the observation method, wet material must be weighed and rearranged inside the drying chamber, and then the drying process takes place during the day, only during the day, from 11 a.m. to 2 p.m. That is when the solar radiation is at its peak, and then air will enter the solar collector. It starts when the air enter the solar collector and double pass it, and the air range about 60 to 75% degrees Celsius inside the drying chamber, and a portion of 12 to 15% of exhaust air will be recycled back inside the system. Okay, this is the overall view of solar dryer. So this is the solar collector, and then this is the desiccant, and this one is the solar this one is the drying chamber. So as a conclusion, this project aims to analyze the solar dryer exhaust air recirculation effect on the regenerative desiccant. Other than that, solar dryer increase efficiency and quality of the product, and also increase the dryness of the desiccant. Benefit the solar dryer by recirculating a portion of the exhaust air, which is 12 to 15% of exhaust air. And then solar dryer effect efficiency must be increased, and the drying time is also need to be shortened to increase productivity. Okay, so this is the things that we need to improve. And then the rate of absorption in the desiccant bed also need to be improved to ensure the increase in productivity of the solar dryer. And lastly, product dryness is the most important component of the success of this project. So that's all from me. My name is Ahya-Elhafiz bin Ahya-Elmuddin. Um, Thank you so much for your time, and see you again soon. Thank you.